There are 6 ratios, okay? 3 of them you should have heard of already. The other 3 you might, I don't know. Sine, it's not sin, okay, it's sine. Cosine, tangent. So how do you make a sine? You go opposite side over hypotenuse. Cosine is adjacent side over hypotenuse. Tangent is a combination of both, opposite over adjacent. If you don't know what those words mean or you forgot, we're going to talk about it in a second, so don't worry, but those are the relationships, okay? You could say opposite over hypotenuse or opposite divided by hypotenuse, whatever you want to think of. And then you have cosecant, secant, cotangent, okay? Now, there's 6 of them total, but they kind of pair up. Kind of look at them, they kind of pair up. Like if I'm looking at sine here, which one matches, or which one's very close to sine? Yeah, cosecant, right? Just reciprocal, that's all it is. So if I know what the opposite is, and I know what the hypotenuse is, guess what? They're going to stay the same, they're just going to flip. Same thing, cosine and secant. Same thing, tangent and cotangent. Okay? Okay, so what do opposite, hypotenuse, adjacent, what do all those mean? Well, let's take a look at it. Let's look at example number 1. So today we're only going to do the first 3 examples. So there's, I think, 5 or 6 problems. We're only going to do 3. So we'll do the first 3 today, and we'll do the last ones the last 3 or 4 problems on Wednesday, okay? Just to kind of ease you in so we don't have to do the whole thing today, okay? Because I know the first day, is kind of slow for me too, so we just want to kind of ease you in a little bit, okay? Okay, so let's start with Math 2. This is kind of the Math 2 stuff. So when you see the word ratio is a fancy word for fraction. In elementary school, before they teach you what a fraction is, they call it a ratio. And then they change the word, and then they say a fraction, and then they stop using ratio. So you never really see ratio 3rd or 4th grade, and then they call it a fraction. And then they call it a fraction up until really high school. And then you see ratio again, you're like, what is a ratio? It's just a fraction. That's all it is. It's just a fraction. It's a fancy word for fraction. So what we got to do is come up with the fractions that make this up. So the first one, sine of A. So angle A. Okay, so let's look at the triangle first. It's got 3 angles, A, B, and C. It's got 3 sides, X, Y, and Z. Okay, so what's the difference between an angle and a side? I'll show you the difference. Angle. How wide, how open is this door? The angle's pretty small, right? It's not open very big. The angle got bigger. The angle got a lot bigger, right? And then the angle got smaller, right? It's the opening. Angle is an opening. Okay? So A is opening, B's opening, C is the biggest opening. That's a 90 degree. Okay? X, Y, and Z side lengths. What are side lengths? Well, side lengths, I need one of these, right? So I'm going to measure something. I got to measure how long something is, right? How long is it from that door to that wall there, right? That is a side length. So they're different. They're not the same. Okay? So when it talks about A, we're talking about only the angle. Okay? So the first thing I do is I label the angle there. We're at A. I'm at angle A. I'm at that opening there. Okay? So at the top, what is the fraction for sine? What is the ratio for sine? What does it say on your notes? What is the ratio for sine? What does it say up here? Say it again. So yeah, but what does it say up here though? Opposite over hypotenuse, right? Opposite over hypotenuse. Okay. So if I'm at A, which side, not angle, which side is opposite, not close? X, Y, or Z? Y, right? Y is opposite. X and Z eventually will touch A, right? They touch A. If something touches, it's not close. It's not far away, right? It's close. So that's why x and z are not opposite of a. So we got y here, right? Opposite. Hypotenuse is always opposite of the right angle. So the right angle is here, right? So which one is farthest away from the right angle? X, y, or z? Z. Okay. So the ratio for sine of angle A is y over z. Okay. Let's go to the next one. Cosine of angle. So we're still at A. What is the fraction for cosine? What divided by what? Or what over what? Adjacent over hypotenuse, right? We're still at the same location. I'm still at the same location. So hypotenuse is still going to be the same. So what was hypotenuse for A? Z, right? So guess what? It's going to be the same. So I'm up here now, right? Which one is adjacent? So what does adjacent mean? Adjacent means next to, touching, next to. Like for example, I have this wall here. This wall, I share with Mr. Yates on the other side. That wall, I share with Mr. Aguila on the other side. This wall, I share with Mr. Lara on the other side. Okay? I'm adjacent to all three of them because we share a side. We share a wall, right? Somebody in the 20s building, I'm not close to, right? Mr. Rodriguez or Miss Beltran, I'm not close to them over there. That would be opposite, right? I don't share anything with them. So when you say adjacent, you mean share. Okay, so let's look at A. Which two sides share or touch A? X, Y, or Z? X touches A, right? Doesn't Z also touch A? Which one of them is going to be the adjacent though? X or Z? X, because Z's already got a name, right? It's hypotenuse. Z's already got a name. So even though that does touch A, we're not going to use it because it's already got a name. So we put X. Y does not touch A. It touches C and it touches B, but it doesn't go all the way up there. It's opposite. That's the way I like to think about it. Okay? All right, so tangent of B, the next one. So now we're changing locations. We're not at A anymore, we're at B. So I'm going to change locations. Down there now, angle B. Now, what is tangent? What over what? It's kind of a mixture of sine and cosine. It's opposite over adjacent, right? That's what it says up there. Okay, so I'm at B now. Which side length is opposite of B? Which side length, X, Y, or Z, is not touching B? X, Y, or Z? X, right? X is opposite. So that goes on top. Which one is adjacent? Touching, but not the hypotenuse. X, Y, or Z? Y. Y, yep. Okay. All right. Sine of B now. We just said sine. We did, for A, we said sine was opposite over hypotenuse. That's still the same. But it's not going to be the same answer because I'm in a different spot now, right? If I change buildings, opposite and adjacent are no longer the same, right? Okay, so B, opposite. So if I'm at B, which side is opposite of B, X, Y, or Z? X. Which one's the hypotenuse? Z. Z is always the hypotenuse for this triangle. Okay, good. All right. So I'm going to do one more of these and I'm going to let you do the rest. So let's skip. We've already done a cosine, we've already done a tangent, we haven't done a cosecant. So let's do G together and then I'll let you do the other 4 on your own. So let's do G together. Cosecant. Cosecant. So I'm at A now, because it says A. What was cosecant? What's the relationship between cosecant again? Yep, hypotenuse over the opposite. So I'm at A. So if I'm at A, which one is the hypotenuse? X, Y, or Z? Z, always going to be Z for this triangle. Location doesn't matter for hypotenuse. Okay, it's always opposite. Okay, so now I'm at A. Which one is the opposite if I'm at A? X, Y, or Z? Y. Good. So the relationship is Y divided, or X, Z divided by Y. The only difference between this problem and the 2 that we're going to do after this is that they're going to give you numbers. They're not going to give you letters. They'll actually give you a number for these guys. That's the only difference. It's the same thing though. It'll always be, sine will always be opposite over hypotenuse. Cosine will always be adjacent over hypotenuse, so on and so forth. Okay, so do the ones we haven't done yet. There's 2 H's. It's a typo, should be I. Okay, so do E, F, H, and I. Give me the fraction. So for letter E, down here. And then cosine we said is adjacent over hypotenuse. So adjacent would be Y, hypotenuse would be Z. So Y divided by Z, or Y over Z. Tangent we said was opposite over adjacent. So I'm switching back now. I'm switching back to A. Opposite is Y, adjacent is X. So Y over X. H, secant of A, hypotenuse over adjacent. So if I'm up here, hypotenuse is Z, adjacent is X. Z over X. And then the last one I'm at B, so I got to switch to B. Adjacent to B is Y, opposite is X. Okay. The next 2 problems are exactly the same. The only difference is they're going to give you numbers instead of letters. It's not going to be X, Y, and Z. It's going to be numbers. Okay? What was I going to say? Okay, I forgot what I was going to say. So let's go to the next one. Let's go to the next one. It might pop in my head. Okay, so example number 2. Example number 2. So there's a triangle. There's one of these guys. One of these guys. I don't know what it looks like. Didn't tell me what it looks like, but one of these guys, for one of these guys, Tangent of A is 5 over 6. There's the answer. They told you it's 5 over 6. Okay? Find in the same triangle, tell me what cosine of A is going to be. Okay? So this is the question here. So this is the given part. This is the question. Okay? What's missing? What's stopping me from finding the answer that you did? Because you did it. You did these. You did cosine of A on number 1. You did it. But what's stopping me from doing cosine of A on this one? There's no triangle, right? There's nothing to look at. Well, we can change that. We can change that. Draw a right triangle. Now, what can it look like? It can look like the one on example number 1. Go for it. It can look like one of these guys. They're all right triangles. What does it look like? What does it have to look like? It's up to you. I would make it easiest for you. Don't try to trick yourself. So I'm going to make my first triangle, for example number 2, look like the triangle for example number 1. Now I'm going to change it for number 3, but since we're still getting used to this, I'm going to make it look like the triangle I had from the last problem. A, B, and C. So they'll never ask you, oh, that's the question I was going to ask you. For this example here, which letter did we completely not use? Which letter did I not use for any of these problems? C. Because C is the right triangle. We don't mess with the right triangle. I don't mess with the right triangle. Never, ever, 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 ever mess with the right triangle. Okay? So when it says A here, it's definitely not going to be the right triangle. Okay? Can A be up here like it was on the last problem? Absolutely. Can A be down here in the corner? Yeah, it could be there too. A and B can be switched. Up to you, whichever ones you want to do. I'll choose A up here. I'll match what I was on number 2, on the first example. I'm not going to keep that way on the next one, just to show you it works, but, okay? So the given part said, hey, at angle A, tangent is 5 over 6. Well, what's the relationship with tangent again? Opposite over adjacent, yeah. Is 5 over 6. So if I'm at A, which one is opposite? Is it A to B, B to C, or A to C? B to C, right? This is the opposite. B to C is the opposite. So they said, hey, that's 5. So I'm going to put 5 here. And then they said, hey, 6 is your adjacent. A to B is not going to be adjacent, right? Because that's the hypotenuse. It's got a special name. So the only other one is A to C. So A to C is going to be 6. Okay. What is A to B? I don't know. So we'll call it Z. I don't know what that is, but we'll call that Z because we don't know what it is. Okay, so now let's go to the question. The question said, what is cosine of A? Well, what's the relationship of cosine? Of adjacent over hypotenuse, right? So I'm at A again. What's the adjacent side? 6, 5, or Z? 6, right? 6 is here. So it's going to be 6 over Z, yeah. It's going to be 6 over Z. If I knew what Z was, I'd be done with the problem. But I don't know what Z is. Now I need you to go back. Math 2, you did this. Definitely 7th and 8th grade, because many years ago, I used to teach 7th and 8th grade. And we did this. This is one of the big things we did. What can I do to find the missing side of a right triangle? It's got called something. So one starts with a P, one starts with a T. Pythagorean theorem. Pythagorean theorem. It's one of those things that you'll always remember. Pythagorean theorem. Pythagorean theorem says when you're missing a side of a right triangle, you can do it. A squared plus B squared equals C squared, that thing. Okay? That's what we're going to use. So, A and B, so when I say A squared plus B squared, those are the sides, the two that make up the right triangle, the right angle. So 6 squared plus 5 squared. The hypotenuse always goes on the other side. What is the hypotenuse? Z. We don't know what it is. That's why we're going to solve for it. So the hypotenuse always has to go on the other side of the equal sign. Always, always, always. The other two go on the other side. Solve it. Okay, 6 squared. 6 times 6 is 36. 5 times 5, 25, equals Z squared. What is 36 plus 25? 61. So does that mean the missing side's going to be 61? That doesn't really match. 5, 6, and 60, that doesn't really go together. What do I have to do? What do I have to do before I can find Z? Sine square root. Yeah, do the opposite. Square root of 61. So how do I find the square root of 61? It's a great question that you've done before. How did we simplify roots a few chapters ago? We did a whole chapter where we did this semester where we simplified roots. How did we simplify roots? The answer is I'm not going to tell you because you've already done it. And if you don't remember, maybe tomorrow we'll have a quiz on it. So what's the easiest way to figure out if I don't know something? Mr. Flores says that we did something a few months ago, but I don't remember it. What's the easiest way to figure it out? Look through your notes. Look through your notes. How do we simplify? How do I simplify the square root of 61? What's the method that we used a few months ago? What's the first step that we did? Tree, there we go, right? The tree was the first thing we did. What two numbers multiply to be 61? Besides 61 and 1. What two numbers multiply to be 61? If you don't know, here we go. Let's try this again. Maybe this will be on the quiz tomorrow. If you don't know two things that multiply, what's something that'll help you? Not your notes, but a calculator. It's right on your desk as well, right? So what are two numbers that multiply besides 1 and 61 that multiply to be 61? 2 times something, 3 times something, 4 times something, 5 times something, 6 times something. What are two numbers? Yep. So what are two numbers that multiply to be 61? There's a reason why no one said anything. Why hasn't anyone said anything? Because there's just 1 and 61. It's called prime. It's called prime. So if there are no two numbers, it's just 1 and 61, right? We can't circle any pairs, so that's as far as it can simplify. Good review. Good review for something that we've done that we're going to see again. So that means this guy is the square root of 61. go back. We kind of did a side quest. Now we got to come back to the actual question. The actual question is, what is cosine of A? Yeah, 6 over the square root of 61. Now, I hate to say this, but we can't finish our answer with a square root, a root on the bottom. Irrational. It's irrational, right? You can't have an irrational number at the bottom of a fraction. Now, how do we change that? It's not hard. I'll show you. And you can use your calculator to do this too. So we're going to take our answer, 6 over the square root of 61, and we're going to multiply. We're going to multiply by the square root, which is square root of 61. Just like that. Okay, so multiply straight across. I get 6 times the square root of 61. Can I multiply those to make 306? 366? Can I multiply 6 times the square root of, or 6 times 61? Could we do that 2 chapters ago when we talked about this? No, because 1 doesn't have a square root, and 1 does. So we can't multiply things that one is in the house and one isn't. 61, the square root of 61 times the square root of 61. They both have square roots. So use your calculator. What is the square root of 61 times the square root of 61? It's a number that'll look familiar. 61. Now we're done. No more square root on the bottom. Can I have a square root on top? Yes. You can have as many as you want on top. Can't have any on the bottom. It's called rationalizing. Okay? All right. All right, one more and we're done for today. It's number 3 and we're done. We're going to do a exit ticket too, but no more new things today. Okay? All right, so here we go. We're going to do one more problem. Okay? Similar type of problem. What are we missing? Triangle. So draw a triangle. Right triangle. Draw a right triangle. It can look the same as you just did. It can look like one of these I drew up here. Whatever you want to do. I'm going to draw one differently than you drew just to show you it's good to see something different. Okay? So my triangle is not going to look the same as yours. That's okay. I'm going to show you how it's okay to do it multiple ways. Okay. Now mine's a right triangle, probably doesn't look like yours, but it's still a right triangle. It's got 3 sides, 3 angles, and one of them is in 90 degrees. Does yours have to look like this? No, yours doesn't. Okay? It's better if they look different. You guys could all have different looking right triangles. It's really the same as this one, but it's just kind of rotated around. Okay? Okay, so we have A, B, and C. C is going to be that guy. A is either going to be the top or the corner. Doesn't matter which one. I can go A on top, A on the corner. Those are interchangeable. Okay. So now let's go to our given information. And then our question. So our given information says the triangle you just drew has a cosecant that's equal to that. So remind me again, what is cosecant? What is the relationship of cosecant? Hypotenuse over opposite. Hypotenuse over opposite. So that means the square root of 57 is the hypotenuse. So yours, however yours looks, the hypotenuse is going to be opposite of your right angle. Okay? So on mine, that's over here. It's not going to be the same on yours because yours triangle looks different. We'll find where it is. Find where it is, okay? And then it said the opposite. Sorry, we're at A. A. Opposite of A for me is B to C. Okay? That is 7. Then I'm missing a side here. I'll call that X. I'm missing a side. So you should have one side that's missing. Okay? Okay. So now let's answer the question. The question says, what is tangent of A? Now, what is tangent? What is the relationship of tangent again? Opposite over adjacent, right? So if I'm at A, my opposite is 7. Should be the same as yours. So verify that your opposite of A is 7. If it's not, you did your triangle, you labeled it wrong. Okay? Your opposite of A should be 7. Everybody should be. Even if your triangle looks like one of these guys over here. Your opposite of A should be 7. Okay? Because we said that earlier. Okay? Adjacent to 7. Or sorry, adjacent to A. Is that going to be square root 57? No, that one's got a special name, right? Hypotenuse. It's going to be X. Yeah, it's going to be X. Okay? So that means I got to figure out what the missing side is. So we're going to do our A squared plus B squared equals C squared. Okay? Remember, the hypotenuse goes on the other side of the equal sign. So if I have an equal sign here, hypotenuse is square root 57. That goes over there. So I have X, and I have 7. Remember, hypotenuse goes on the opposite side. X squared, I don't know. But 7 squared, I do know. 49. What is the square root of 57 squared? Use your calculator if you don't know. It's 57, yeah. Some of you guys remember from last chapter or the chapter before, if you square a square root, it just disappears. How do I get X by itself? What's my next step? Subtract 49 from both sides. 57 take away 49 is 8. Square root. So now we're going to do the same thing. I know 61 didn't work, but 8 will. So let's do our tree for 8. What two numbers multiply to make 8? 2 and 4. Circle the 2 because the 2 can't be broken down anymore. 4, stay with me everyone, we're almost done. 2's, right? Okay, rewrite it. We got 2, 2, and 2, right? Then what do I look for? Pairs, yeah. I got one pair of 2's, so a 2 comes front, and a 2's left over. So that's what the square root of 8 is. 2 times the square root of 2. So that's what I'm going to write down here. That's that missing side over here, 2 square root 2. Okay? Now I have enough information. Now I can put 2 square root 2 on the bottom. Now, if that square root 2 wasn't there, you'd be done. But because the square root is down there, I have to do what I did the last time, right? So 7, 2 square root 2. Now, you don't have to multiply by the 2, just the square root of 2. Okay? We don't want to ask our calculators these questions because our calculator will give us, if you put this in your calculator, it'll give you a decimal. We don't want a decimal. So 7 times 2, can I multiply that to make 14? No, because 1 is inside, 1 is not. So you get 7 root 2. Now there's a 1 here that we don't write, but there is a 1 there. So I can multiply 2 times 1, because those are both on the outside. And I can multiply 2 times 2, because those are both on the inside. To make 4. What is the square root of 4? 2. So really on the bottom it's 2 times 2, which is 4. So tangent of A, isn't it? Okay. All right. So I'm going to give you one problem to do. The problem you do, you won't have to do this part here. You won't have to do this part here. Okay? But I wanted to put those in your notes, so just so that if you do have them later, you know how to do it. Okay? So I'm going to give you one problem like this, and then you'll be done. So don't tape in anything yet because we're not done yet, because we're going to finish on Wednesday. So the last 3, 4, 5, 6, and 7 should be 6 and 7. There's 2 5s. I don't know why. So change that to 6 and 7. Okay? All right, so here we go. Yellow, and you don't have to write down the problem, just do the problem. Okay? Just do the problem. You can use your notes. You can use your calculator. Any of those things. Okay? Make sure you do it, because if I don't see your paper in there, I'm going to count it against you. I don't grade them unless you don't turn one in. If you don't turn one in, then it gets counted against you. You can't make it up. So make sure I get one from everybody. And then tomorrow we'll do some practice.